Hello everyone. Let us discuss some question and answer today. What happens to the force between two objects if mass of one object is doubled and the masses of both objects are doubled? So here we have taken the example of Earth and the Moon. The mass of Earth is capital M and the mass of Moon is small m. The force of attraction between them is capital F and the distance between them is capital R. So we know that the formula for the force of attraction is capital G into capital M into small m by capital R square, where G represents the universal gravitational constant. So if one of the mass, say the mass of the moon, is doubling, then we can write it as 2 into m small m. So the new force, let us consider it as F1 becomes capital G into capital M into 2 into small m, because we are substituting the 2 into small m, that is a new mass, in the place of the old mass by R square. So we can write it as 2 into capital G into capital M into small m by R square. So here you can see that this is the formula for the initial force. So we can write that F1 is equal to 2 into F. So when one of the mass is doubling, the new force becomes twice the initial force. If masses of both objects are doubled, that is 2 into capital M and 2 into small m. So when the mass of the earth is also doubling and the mass of the moon is also doubling, that is 2 into capital M and 2 into small m, then the new force, let us consider it as F2, becomes G into 2 into capital M into 2 into small m by R square. So 2 into 2 gives us 4. So we can write it as 4 into capital G into capital M into small m by R square, and this represents the initial formula of F. So F2 is equal to 4 into F. That is 4 times the initial force. So you can see that mass is directly proportional to force. So when mass increases, the force automatically increases. That is why when one of the mass is doubled, the force becomes twice the original force, and when both the masses are doubled, the new force becomes 4 times the original force. Now let us answer the second part of the question. That is, when the distance between the object is doubled and tripled, what will be the force? So here the distance is now getting doubled and tripled. If the distance is doubled, then the new distance, let us consider it as R1 is equal to 2 into R. So F is equal to capital G into capital M into small m by R square. That is the formula for force. Now we are substituting this new distance in the place of R. So the new force, let us consider it as F3, becomes capital G into capital M into small m by 2R whole square. And we know that the square of 2 is 4. So we can write it as capital G into capital M into small m by 4R square. So see, this is the formula of F. Capital G into capital M into small m by R square is the formula of F. So we can write this as F3 is equal to F by 4. If the distance is tripled, then the new distance, let us consider it as R2, is 3 into R. So the new force, let us consider it as F4 becomes capital G into capital M into small m by 3R whole square. And 3 square is 9. So we can write it as capital G into capital M into small m by 9R whole square. So this again is the capital G into capital M into small m by R square is again the formula of F. So we can write it as F by 9. So R, that is the distance, and force is inversely proportional to each other. That means if the distance increases, the force decreases. And if the distance decreases, then the force will increase. So when the distance is becoming double, the force is becoming 1/4 its initial force, and when the distance is tripling, then the new force is becoming 1/9 the initial force. That is, it is decreasing by a lot. That would be the end of the video. Thank you for listening.